Okay, question 6 has given us two functions. G of x is made up of two kind of mini functions, x minus 2 all squared plus 1. So that's the first part here, up to 2. So we've got, this is a marker of 2 here. And then for x greater than 2, it turns into the straight line graph 4x minus 7. It wants us to work out g of 0. So we need to decide which equation we're going to find first for g of 0. So g of 0, we're going to use the top equation because x is less than or equal to 2. So we're going to do 0 minus 2 squared plus 1, which is going to be 5. But then because 5 is now greater than 2, to work out g of 5, we're going to put that into the second one. So that's going to be 4 lots of 5, take 7, which is 13. Part B says find all values of x for which g of x is greater than 28. So if you look at the curve, we've just found out that when x is 5, we get a height of 13. When do we get a height of 28? So there's going to be 2 times that happens. It's going to be once from the x minus 2 all squared plus 1 equation, and there's going to be one from the 4x minus 7 equation. So I'm just going to substitute that into each of the equations. I'm going to make x minus 2 squared plus 1 equal 28 and solve this. So that's going to be x minus 2 squared is equal to 27. X minus 2 is going to be equal to plus or minus root 27. So x is equal to 2 plus or minus root 27. However, we want the negative answer. We want a negative answer for this one. So it's going to be the 2 minus root 27. But it was an inequalities question. It wants g of x to be greater than 28. So g of x will be above 28 when x is less than 2 minus root 27. And if we do the same thing for the 4x minus 7, it needs to be greater than 28. If I add the 7 on and divide by 4, then I need x to be bigger than 35 over 4. So those are my 2 answers. I've got x needs to be less than 2 minus root 27, or x needs to be greater than 35 over 4. So h of x is now the x minus 2 all squared plus 1 function. So h is just this line here. This now doesn't exist for h. It exists for g but not for h. And it says, why does h of x have an inverse but g of x doesn't? So because h is just this, it has an inverse because it's a 1-to-1 function. So h of x is a 1-to-1 function. So that means that for every single one input, it has exactly one output. That is not true of g of x. G of x, if I add on g of x here, g of x then does this. This has multiple inputs that give the same output. We've just found that 28 can be found from having an x value of 2 minus root 27 or an x value of 35 over 4. So that is a many to one function. So many inputs produce the same output. Multiple inputs give one output. Only one-to-one functions have inverses. Okay, so then part D asks us to solve the inverse of h equal to -1/2. So we can do this two ways. We can work out h of -1 of x and then solve it equal to -1/2. But there's another thing we can do as well. And the other thing we can do is we can just work out h of -1/2. Because with inverse functions compared to their originals, the inputs and outputs swap over. So if we want an output of -1/2 for the inverse, that's the same as giving an input of -1/2 to the original. So this will save us a little bit of time. I can just work out -1/2 minus 2 all squared plus 1. So that's going to be -5/2 squared plus 1, which is 25/4 plus 1, which is going to be 29/4. So x will equal 29/4 in the inverse function that will give us an output of -1/2.